Hi students, welcome to HSC Earth and Environmental Science and Module 7 Climate Science. This is video number 21 and it's the beginning of our last little section on climate science. And in this video we're going to spend a little bit of time talking about fossil fuels and the enhanced greenhouse effect. So one of the things that we want to do now is we want to see if we can link some of these human-induced causes for enhanced greenhouse and try and break some of them down into areas where we've perhaps can do something to mitigate and perhaps areas where we might be able to turn things completely around. So this section is called the mitigation and adaptation strategies. So what we want to try and do here is to see if we can take all of the data that we've been bringing together from all the different areas, both historical data, paleo data, as well as some of the things that are going on presently, some of the measurements and instrumental records that we have currently, and how we apply them into what might be the case in the future, certainly if things don't change and potentially if things do. So this final question is really motivated by whether or not there is scientific evidence that demonstrates how humans could minimize and respond to the effects of increased global temperatures. This is one of these inquiry questions that we like to do a little bit of brainstorming around. And in fact, as I've recorded this, we've already had a bit of a look at this in class already. So that brings us back in a fairly large circle to the whole idea of industrialization. And we have talked before about the Industrial Revolution and the significant impact that it did have on the atmosphere, on general levels of heating, on social life as a whole, but also on things like mining, the importance of coal as part of the economy, and this increasing amount of pollution that was being released as a consequence of all these engines now starting to use coal as their fuel source. So we know that fossil fuels for energy began with the Industrial Revolution, and then about 100 years later we had large-scale uptake of these processes across Europe and also North America. We see continuing today, probably the most populous nation on earth, China, continues to be very highly industrialized, have a very high uptake of energy, or at least a very high energy usage level, but a lot of other countries as well that are still looking at ways of being able to effectively generate energy, the energy they need to supply electricity or power. Now this isn't always done through those old fossil fuel mechanisms. In fact, it's increasingly being done by a number of different alternate forms, but we'll look at some of those a little in future videos. So one of the things that's important is the fact that we've still had a bit of an increase. We can still see some areas where there's been a bit of an increase in this reliance on fossil fuels for energy generation. Now it's fair to say that if we're going to try and look at the enhanced greenhouse, and remember when we're talking about enhanced greenhouse, what we're talking about is not the natural greenhouse, not the natural processes that are putting carbon dioxide into the atmosphere and increasing the levels, or perhaps some of the fluctuations that we've seen in some of the levels occurring over many, many years. What we're talking about is a greenhouse effect that's being accelerated, that is going faster than what we would otherwise expect that it would. And so what this does is it means that we need to have a look at some of the potential areas that may be contributing to these increased or enhanced greenhouse gas emissions. So when we split that into economic sector, as you would probably expect, electricity production and also heating make up about a quarter of those greenhouse gas emissions. If you think about another quarter being responsible in the agricultural, forestry and land use industry, and in fact we'll look at land use in a little more detail in the next video, then we've got pretty much half of our greenhouse gas emissions covered already. There's often some overlap between the types of industries that will be reliant on the processes that will lead to greenhouse gas emissions, and to a direct relationship often with transport mechanisms. So you can see a lot of these different types of industries or economic sectors will feed into one another, and together will create a very large concern for us in terms of the amount of greenhouse gas emissions that we have. But probably what's more concerning, I guess, at least relatively recently, probably within about the last 5 or 6 years, is the fact that the top 10 nations contribute over 2/3 of our global emissions. And by far the number one on this list is China. And that does have a lot to do with population size and also the area, the actual land area of China. But you can see that primarily, again, and this is the case for a lot of these nations that are doing a lot of greenhouse gas emissions, their primary use for those processes that are going to generate greenhouse gases is for electricity production or for heating. And so we find China's up there, the United States is up there, and Australia doesn't quite make the list, but unfortunately for us, we are kind of punching a little bit above our weight in terms of our population. We've got a big land area, but we've got a very small relative population, and yet we're still in the top 20, and that's not a good thing. Here's some of the contributions to greenhouse gases. Here's some of the problems in a sense of what are we going to do about these massive contributions to greenhouse gas emissions, to this enhanced greenhouse effect. How are we going to try and address some of these areas? Fossil fuels include coal, crude oil or petroleum, and natural gas. Of these three different types of fossil fuels, the cleanest is natural gas. And this is because it is primarily made of methane. And the consequence of that is that we get less emissions of sulfur oxides and nitrogen oxides. And these are the ones that can often lead to additional complications such as acid rain. Whilst there are many problems associated with the use of fossil fuels, and the enhanced greenhouse effect is one of the most serious, it is also a finite resource. We know that our stores of things like coal are going to run out. And we also know that there's been a lot of global tension around the control of crude oil or petroleum. And these are going to continue to be under high demand unless we can look for alternative sources. The other thing that's probably the most significant thing about the burning of fossil fuels is the fact that it is a major counter to the processes of carbon sequestration. So this is basically taking carbon dioxide and locking it up into a solid form or a liquid form. And what this does is it takes it out of the atmosphere. It keeps those levels in the atmosphere lower. So we try and do this, and one of the obvious ways of being able to do this is to do it through storage of carbon dioxide in plant tissues. Now, this could include being transferred into animal tissues through the processes of assimilation when animals eat plants, but it's also going to then be released when, for example, the animal dies, or when the animal carries out respiration, or even when the plant carries out respiration, and some of that carbon dioxide is returned to the atmosphere. Now, if these processes occur in a cyclic manner, then we don't have a problem. What we do have a problem with, though, is where some of the carbon dioxide that has been converted into coal or perhaps into oil, and so therefore these are processes that take millions of years, then we burn them and release that carbon dioxide back. We just can't bring that carbon dioxide back into these forms anywhere near as easily. And as a consequence, this is having such a significant effect on those levels of carbon dioxide that we've actually had to refer to it as an enhanced greenhouse. We're putting that carbon dioxide back at a much greater rate than what we're able to pull it out. And this is one of the reasons why there's a lot of research and money being spent in trying to determine how we could effectively use strategies to take that carbon dioxide out of the atmosphere and put it somewhere, whether we build biomass through building more plant tissue or some other way of being able to extract that carbon dioxide. And that's, of course, something that we're going to be looking at in future videos. Thanks for watching.